Our instructions in 1D are to divide function f and g. So we want to take function f, which is 3x squared minus 4, and divide it by the function x squared minus 8x plus 4. Now remember, our emphasis throughout the year has been that a fraction bar is a grouping symbol, and we can omit those symbols if you want, but if I put them in there, maybe it makes it a little bit easier to think about simplifying. We cannot simplify on division unless this factor, this number, is the same as that number. And since these numbers aren't equal, this is our solution, or this is as far as we can go with the division. So the division side of this is really not a big deal. We indicate that we want to divide the two functions, but there's no simplification that occurs, so this is what f divided by g of x. The work in all division problems comes into when we have to indicate any restrictions on the domain. Now, I didn't worry about that in A, B, and C because they were adding, subtracting, and multiplying, and there really aren't any restrictions that we apply to those three operations. But what we do have to be careful of is whenever we divide, we want to make sure we never divide by 0. So we want to make sure we don't divide by 0, so that means I got to make sure that the x squared minus 8x plus 4, when is it equal to 0? I want to figure out when it does equal 0, and then I'm going to make the restriction and come back and say, don't let x equal whatever I determine those values to be. So we're going to restrict our domain, our inputs, by finding out what values they cannot have because it would require us to divide by 0. So first thing I got to do is I got to recognize what kind of equation I have. It's a quadratic equation, so we have some different strategies for solving a quadratic equation. One of the ones we think about, or I think about immediately, is factoring. I don't like my odds of factoring because there aren't any factors of 4 that will add up to an 8. So then I'm going to transition right into the quadratic formula. So in order to find those values of x that equal 0, I take the opposite of b, which is opposite of a negative 8, which is 8, plus or minus, the square root of b squared, which is that 8, negative 8 squared, which is 64, minus 4 times 1 times 4. So minus 4 times 1 times 4 is minus 16, all over 2 times a, which is 2 times 1. Then I'm going to do a series of simplifications. Now we're going to chug a little bit after we plugged in. So we got the square root of 48 all over 2, simplifying the 64 minus 16. The square root of 48, I'm going to bring that over here in kind of a little bubble. The square root of 48, what we're going to do is take out any perfect squares that are in 48. So one of the factors that's a perfect square in 48 is 16. And 16 times 3 is 48. So I've just rewritten 48 as a product of those. But the square root of 16 has a benefit is because square root of 16 is 4. So this simplifies to 4 square root of 3. And there aren't any other perfect square factors than 3, so I stop with that part of it. So I know I have it in simplest radical form, and that's all over 2. Now we want to distribute our division, so we want to take each of these, so the 8 divided by 2, and the 4 square root of 3 divided by 2 to put it in simplest form. And we get an answer of 4 plus or minus 2 times the square root of 3. Now these are the values of x that if I put them in, we would get exactly a value of 0. So that's our restriction that we want to make. So we finish this off by saying for our domain, what we want to make sure that it never is we want to make sure that x's cannot be either a 4 plus or minus 2 times the square root of 3, because that would cause us to divide by 0. So here is our restriction that we're looking for. Make sure you find the restriction for all division problems. There should be some type of restriction that you need to go find. That's where most of the work comes in on those.